Hi, welcome to Solving Science. I think this is number 17 now. For a couple of theoretical physicists who I know have been following the channel and giving me a lot of support, to Elliot and Felix, wow, this is a big video. It's a big video. This might actually be the most compelling evidence yet for expanse tension theory. And a quick reminder, if you're new to the channel, I'm the originator of an idea called expanse tension theory and then general expanse tension theory. And what I do in Solving Science is apply that theory to phenomena, mysteries, anomalies, paradoxes in the universe to see if that theory solves them. And today, wow, it's the Milky Way. So let me explain. 5 months ago, expanse tension theory exposed a baryonic density threshold of 10 to the minus 21.6 kilograms per meter cubed as a transition point in physics. And we identified it. I then went on to prove that that exact density threshold works with 175 galaxies in the Spark database of other galaxies to a chi-squared confidence of 0.985, which actually is like compelling. It's 1 in 10,000 chance of being by random chance. So you can find and see within the Spark galaxy database that transition point, 10 to the minus 21.6 kilograms per meter cube baryonic mass density. So then what I did is think, well, the European Space Agency's Gaia telescope is almost like a video camera recording the transition and movement velocity position of stars within the Milky Way, within our galaxy. And actually, for the amount of data that Gaia is collecting, all publicly available, what if I could find a transition point in velocity in the Gaia data? So what I did, which any of you can do it right now, publicly available, go to the European Space Agency, go to the Gaia missions, you go to a search. It's complicated. I ran a sample search triggered by a particular search. I'll explain how I've done it in the paper. I downloaded 6 million star sample database in 2 samples of 3 million stars. And I looked at vertical velocity. Now, we're all familiar with galaxies are rotating, and we know anomalous rotation, flat rotation curves, flat rotation speeds prolong through the low density outer regions beyond what visible matter can support. We know that. We call it dark matter, although it's a ridiculous term where we labeled the problem with what we think the answer might be, which is awful. Anyway, 92 years dark matter, haven't found any for 92 years. Anyway, as well as the rotational velocity around the stars, stars also fluctuate in height, in Z, about the midplane, and the gravitational attraction, the restoring forces of the galaxy are also part in controlling the height and velocity of stars that are moving in height, in Z. The research I've done is that by using vertical velocity, you take out some of the real complexities of modeling rotational speed. So what I've done in a paper that's published on Zenodo, and I'll link to it in this paper, is use these 2 3 million star samples to look for the transition point in our own Milky Way. And I've ran a statistical test purely looking at, does the transition exist around a baryonic density threshold of 10 to the minus 21.6 kilograms per meter cubed? The exact density predicted 5 months ago. The density that about 4 months ago I proved was statistically significant in the Spark galaxy database of other galaxies. And now the question is it present in our galaxy? Well, that's the smoking gun chart in this. By the way, that trigger point here, a sample of 6 million stars, is at 10 to the minus 21.6 kilograms per meter cubed in baryonic density. Now, this is what you call kind of dark matter velocity. This is an unexplained transition point. This is greater velocity in an extremely low dense environment. There isn't enough baryonic mass to trigger Einstein's gravitational attraction to curve space-time as Einstein would have you see it, in order to restore the force. So these stars are rising in height z about the midplane at such a speed their baryonic mass restoring force of the surrounding environment shouldn't be able to restore them, as in bring them back to the midplane. Yet they are. Now, the clever thing is that I really like about this paper, it's not theoretical in any way, shape or form. It doesn't rely on expanse tension theory or general expanse tension theory. It's not theoretical. It is a 100% empirical piece of analysis. You can go and download 6 million stars from the European Space Agency Gaia database, run the analysis. My paper shows you how to do it, and you can reproduce this result. Now, if this is validated, verified, reproduced, replicated by others, well, what does it mean? It means baryonic mass density is the causal factor of this anomalous higher velocity relative to baryonic, the environment baryonic mass, as in dark matter. The analysis also very carefully says the answer is not, as in what's not causing this anomalous transition is geometry. It's not radius. It's not the galactic halo. Not acceleration. Now, the fact that it doesn't correlate to acceleration tells us something, because the world's current leading galactic model in development, a theory that's been around for a long time, many decades, modified Newtonian dynamics, relies on the idea that acceleration is the trigger point. And this analysis says, no, it isn't. It's baryonic mass density. So where does this leave us? Firstly, this, I think, could be a smoking gun. An empirical, publicly available, reputable data set from the European Space Agency's Gaia mission, 6 million star sample, a 99.998% confidence, mostly driven by that huge sample size, 7 sigma result. Okay, the probability, the chance that this result is happening by statistical random chance is basically non-existent. This is fact. So, if this is true, which it appears it is, and it's reproducible, then it begs the question, if baryonic mass density is the trigger point in our Milky Way for the transition to anomalous, flat speeds, velocities, and this is remember, a vertical velocity, not rotational velocity, although I'm confident we would see the same effect, then it begs the question, what is the underlying causal mechanism of that? And that's where general expanse tension theory comes in with several new theoretical solutions. So anyway, thank you for watching. This is a really exciting one. I'll link to the document. Please follow, subscribe. If you're new to the channel, please go back to the beginning, watch the series development in order, because you'll see how the series develops. And thank you for watching. If you know physicist, cosmologist, astrophysicist, anybody at the European Space Agency, anyone interested in physics or science, anybody studying physics or science. Remember, we've been looking for dark matter as a humanity for 92 years, and we haven't found any. We've been looking for dark energy for 28 years, and we haven't found any. General expanse tension theory is a solution that doesn't rely on the search for invisible, undetectable, new, unknown sources of matter or energy, which I think are labelled badly, where you've labelled the problem with what you think the answer might be. Anyway, thanks for watching, and let's try and solve the universe. Bye-bye.